So we are going to continue. We were basically talking of how we just in the part of interference experiments and how did we account for, how did we do away with the causal anomalies, or how we can account for them. So which led to some different interpretations of quantum mechanics, which should not lead to which should lead to an understanding which is not contradictory, or which is compatible with how we can interpret experiments. So in that context, there have been interpretations which we can account for causal anomalies and otherwise also. And in that we also accounted for the pilot wave idea, which had its own, it explains things, but the very idea of pilot wave, piloting the wave, entire wave, such that the energy is localized at a certain point, it also leads to sort of causal anomalies as far as whether the oscillating particles can trespass one path or simultaneous paths along different trajectories. So these interpretations can be somehow, we can talk of restrictive interpretations and exhaustive interpretations. And later we can also include one more interpretation to it. That's it. So in restrictive interpretations, whether we have a corpuscular interpretation or whether we have a wave interpretation. So we are going to emphasize, or we are going to only concentrate or restrict our observation only via one particular attribute. So if we can concentrate either on the particle attributes or in the wave attributes only. And in the exhaustive interpretations, we take all these both waves and particle interpretations simultaneously together, so that nothing is left out in our accounting of things. So, but both of these interpretations, there is something which we might, so there is an idea. We talked of phenomenon and interphenomenon. The very interphenomenon and phenomenon, what was the difference is that in interphenomenon we had the idea of interpolation. The idea of causality was somehow intertwined with an observer, two observers which were not maybe causally connected in that sense. So the effect can be traced to some two different causes, or two different observables, or two different parameters, you can say it that way. So in exhaustive interpretation, what is that the interphenomenon is the idea of how we can do away with causal. The point is how to do away with the causal anomaly, which comes, for example, if we have a pinhole and diaphragm, which we try to explain it. So if the particles come, you have an impression here or here or wherever it is on the screen. But if we open both of these holes, we cannot say the impression which has been created, whether it's a dark spot or a bright spot. It may be due to one of the particles entering here or this point, or simultaneously particles entering both of them. So somehow causality seems to be, you have to adjust how we can do away causality. Causality seems to violate it in the sense we cannot exactly pin down whether the particle which has come from this point, it created impression out there, or it has come from this point. It created, so if there was some lag between these two particles or waves entering this point, if the ultimate thing is in terms of corpuscular or in terms of waves, so if entering this diaphragm, so we are not able to pin down exactly which impression you could get it. So it seems that causality as such, the impression, it seems to be you cannot account for causality, and which is also called causal anomaly. Now the question is, in whether we take a restrictive interpretation, we'll only concentrate on the particle aspect, or we'll only concentrate on the wave aspect, or we'll take exhaustive interpretation. We'll take both of these particle as well as wave, somehow embedded in this wave particle duality sort of thing, and somehow how we can explain these two interpretations, and how we can do away with causal anomaly, which will it also lead to other things. Whether causal anomaly can be done away, that if we only restrict it in terms of phenomena or interphenomena. So here this thing, the observables are not the impressions which are connected. So it's intricate in that sense. That's it. That's it. Now the question is, how can the elimination of or eliminability of causal anomalies. So that's our job, at least to find an interpretation which is not an anomalous interpretation. We can have causal anomaly, but our description should be not anomalous, or it should be more convincing. So if it has to be more convincing, so it's also not only how, so it becomes important to pin down how can relate phenomena in terms of interphenomena. You can say that phenomena is a interphenomena of very simpler kind in that sense, and interphenomena can generate a class of phenomena. That's it. Apart from the other interphenomena, you can have it. So we can have, for example, so it's better stated like this: we do not have one normal system of interphenomena, but we do have normal system for every interphenomena. So the question is, not only when we talk of Heisenberg's principles of interdeterminacy. So we have two conjugate variables, whether it's position or momentum, energy or time. We say, so the determinism, which was previously associated with determinism, rather causal determinism, and became suspect when we take two simultaneous conjugate variables. In simultaneous conjugate variables, maybe you could say it is an exhaustive interpretation coupled to the phenomenon of interphenomena, which is somehow related by some sort of interpolation. So if this causal determinism becomes suspect, we can say it is related with the principle of eliminability of anomalies, which is called causal anomalies, is made possible via or through the principle of indeterminacy, or invariance, you can also say. That's it. So we can say eliminability of anomalies. So we can say we cannot fundamentally determine. So we have one limitation. We are going to justify it by some another limitation and as a sort of a principle. So it's like you cannot do this thing because you cannot. If you cannot do this thing, it's because you could not do that thing. That's it. So if you could not have this causal anomaly cannot be eliminated because we invoke the idea of we cannot fundamentally determine things, or causal or determinism as a philosophy has to be taken away, not taken strictly. So it's taken as a sort of principle. The indeterminacy of causal anomalies is taken as a sort of principle. So probabilistically, how we can imagine it, we can also have a probability interpretation of this entire thing in the sense that for example, if we have, for example, the way we had this diagram, so it's B1. So we have. So if it's A, it's B1, B2, it's C. So what we have to see if something comes. There are two pinholes. So it comes from this. It has an impression here, or it comes from this. It has an impression here. The impression may be either individually due to this, something coming from this point, or particle or wave coming from this point, or simultaneous particles and waves interfering and they producing impression out there. So these are different probabilities, and if we want to just pin it down, that for example we can say that in a language which you can sort of say it's a symbolic language, and the way things have been done in this book or otherwise also, there's a symbolic way of, there's a relationship. The idea of quantum mechanics, the idea of invoking interdeterminacy, you can interpret also as in terms of how we can symbolize these things in terms of logical constructions, which can be mapped to some things which we can do, which we cannot do, which we can determine, which we cannot determine in terms of that symbolic language. The role of symbolic logic and language of quantum mechanics, how they can be related. So in the early simplest sense, probability of A, B1, B2 can be written as whether this probability of A, whether it has gone through B1, B2, it can be this can be either probability of E times B1 or sum of probabilities of E times B2. Probability of wave or particle emanating from here, it's sum of probabilities of this and this. That's it. And this sign means, so we have, this is the sign here, V. It's means or. Yes. So it means that, so whenever a wave leaves A, whenever a wave, for example, leaves A in the direction of B1, so there is another wave simultaneously in the direction B2. There is another wave simultaneously in the direction of B2. Namely, in all those cases when the corpuscular interpretation of particle emitted is thus controlled by, so it's controlled by it as at an action at a distance. And here comes the subjective interpretation. For example, a physicist who would want to explain a one well-confirmed relation will prefer, so you can have preferences, how you can interpret this experiment, will prefer to corpuscular interpretation. Without the thing, whether it's anomalous or not, whether anomaly is a causality is violated or not simultaneously. If you want to say it, the probability here is the joint effect of probability of this and this at this thing. The impression created out here is the joint effect of this and this. So which is can be summarized in terms of this logical relation. So a particular preference of this interpretation can be this way. If you want to have a particle interpretation. Now the question is, if you do not have this as a particle interpretation, if you do not have this corpuscular interpretation, so what can you do with the other part of this interpretation? Where, for example, when you try to pin down its, so the other part of it is in a given experiment, you cannot design in any experiment where you can conclusively show only particle thing, whether it's particle or wave. So if it's if you only concentrate on its being particle, you cannot design an experiment which you only have one aspect only, or you cannot design an experiment which will concentrate only on the wave aspect only. So in that case, this explanation, this preference, this thing will not, this preference, so it will have the causal anomaly cannot be done. Causal anomalies cannot be done away with. That's it. So if that is the case, so it doesn't basically break down to you are just trying to see that there is inherent problem in picturizing things out here. It's somewhat intrinsically the nature is like that. One is, it's not that we are there is a problem in our when we conceptualize things and how we can have a picture of them or how we can formalize them. It's not that. It's basically nature is more like that. That's the point. So which has been articulated by people like Bohr and Heisenberg, and that's it. So this articulation is there. So which is that laws of phenomenon, laws of internal phenomenon or not? So it means that we can this thing. So how we can relate it with how we can see whether we have a restrictive picture. So restrictive picture means we only take particles and or particle at a time or wave at a time. In exhaustive picture we take particle wave together. So whether we have restrictive picture or exhaustive picture, in the exhaustive picture we have a more thing called interpolation, or we have a more thing, we have invented a thing called interphenomena rather than phenomena. So if we have, for example, so you can, in the history of this thing, the restrictive picture has been pioneered by, restrictive picture has been pioneered by, Bohr and Heisenberg. And here we talk of phenomenon as compared to interphenomenon. And statements are about measured quantities. So I forgot to say in interphenomenon, in the exhaustive interpretation, interphenomena is somewhat related with also with unmeasured quantities. That's it. So unmeasured phenomena, the statements of unmeasured quantities become meaningless. So that's it. Now, so we are going to come to a very so another, which I talked in the beginning of the lecture, there can be apart from this these two interpretation, exhaustive interpretation and restrictive interpretation, where we can how we can do away with causal anomalies by the introduction of phenomenon or interphenomenon. So that's it. So this is one part of it. So we can also have another interpretation, which is basically how we can see that it has somehow more or less relation, how we can formalize things, how the relationship of language and logic. And in language, we have how we give meanings to these restrictive and exhaustive interpretations. And there can be a third possibility where we use the word indeterminate is given some, we give some value or meaning to this thing. So we are comfortable that the word we cannot determine simultaneously two conjugate variables in an exhaustive interpretation. So what we say is that statements about unobserved entities are neither true nor false. They are indeterminate. So we have introduced another column here. So So in the former sense, if you just introduce the words of logic, Boolean logic, or general logic, we say it's two-value logic. The quantum mechanics or classical mechanics is it has either it's this or it's that. It is true or it's false. So it cannot be either. But we have included neither it's true, neither it's false. It's indeterminate, and this indeterminate it also has some. It's not to be done away with. We introduce a third preamble or parameter, or in this thing. It's true, it exists, or it's wave, it's particle, it's either, or it's indeterminate. That's it. Statements about unobserved quantities, statements about unobserved quantities are considered meaningful they are neither true nor false, but indeterminate. Yes. So this entire exercise. One is the two-valued logic. So we have introduced a three-valued logic. One is true, false, and other. It's neither true, neither false. It can be indeterminate. That's it. So quantum mechanics follows a three-valued language or three-valued logic. So because as causal anomalies which are formulated by exhaustive interpretations appear to be superfluous complications. And they cannot account for the observable nature, what we observe in the nature. So that's it. So our problem in the restrictive interpretations can be formulated as so if there is problem with the exhaustive interpretations, that it introduces causal anomalies at the cost of what we are observing things, but in case of restrictive interpretations, what's the problem? We express so you can say restrictive interpretation is also a sort of as a class of exhaustive, it's a subclass of exhaustive interpretation and causal anomalies can be transformed away locally because in restrictive interpretations we only have the effect here at this point is the effect, joint effect of two probabilities, two things. So in the sort of a corpuscular way, so you can see it. So locality is somehow preserved in this restrictive interpretation. They do not say anything about causal anomalies, but in a restrictive interpretation we cannot also remove those causal anomalies. So the principle of interdeterminacy, what it helps is, it helps us to clarify certain phenomena about certain phenomena, about how we characterize interphenomena. So it accounts for this thing. It accounts for our inadequacy. So it doesn't. What it says is basically what it says is that things which are indeterminate, they can also be meaningful. They have not to be done away with, or they have not in our language. If we cannot understand something, we do away with it. It doesn't carry sense. So that's it. So it can still be meaningful, and in that sense, it will account for interphenomena, which is related with the exhaustive, how we interpret, how we formulate, or how to formalize exhaustive interpretations. Yeah, and that's it. So at the end, here at the end, you can see, if you read the last sentence of last paragraph, you come to the way Reichenbach has his own way of just articulating the state of affairs of the thing, or Reichenbach's way. What he says is that so if causality as a phenomena was sacrosanct, or causal determinants was sacrosanct in the classical way of looking at things, and in quantum mechanical way of looking at things, the causal determinism was seen not to be working that way. It should not lead us to sort of it should not lead us to sort of saying that there are fundamental limits of we cannot nature fundamentally or know things, or causality is not to be taken. What he is trying to say is that even the indeterminate aspects of nature, which is formulated in terms of this quantum mechanical rules, which have causal indeterminism associated with them, even the formalization of those rules which help us to explain the physicality of the world out there, so that should be taken as a principle. So it may be a sort of a deviation from the way classical mechanics or causal determinism had been there for 2-3 centuries prior to the evolution of quantum mechanics. So he is not questioning this the empirical part of it, the empirical, logical empiricism, logical, empirical part of it. He wants to say that not logical, the empirical part of it, which was basically part of how we formulated causal determinism in the classical sense. But in the quantum mechanical sense, there came causal anomalies. So the coming of causal anomalies in no way should somehow we can account for those causal anomalies in a sense that there are some rules by which still we can explain or formalize the way of world which is out there. And it in no way should say that beneath nature is somewhat not deterministic in that sense. It doesn't. So basically, Reichenbach is echoing a certain philosophy, underlying metaphysics, or a philosophy of logical empiricism. That's it. And materialism, where things have been. He still wants to have faith in scientific empiricism, or so he doesn't want that one should interpret things any other way, whichever way that it will lead us to. So you're saying that at least we can formalize those rules, even if those rules cannot be formalized within the parameters of causal determinism. That is in itself an achievement. But whether those formalization of rules, if it's not um, strictly deterministic in that sense, still it's an achievement. But does it say about some fundamental philosophy? How should we view nature? On this, Brighton book is what I should say. He is somehow converted. He doesn't want to go away from the empirical empiricism as it was. He doesn't want to deviate from that very thing. So that's the point. So here I'll stop in this lecture. Thanks.